3 over 2. So there's one line. Now graph the other line. Okay. Bam, bam, bam. Where do they meet? Where do they meet?
All real numbers.
Not all real numbers. Do they meet here?
No, you put the, what's called down infinity?
What points do they meet at?
Infinite number of solutions.
3 and
Not how many. What points do they meet at?
negative 3 and positive
All the
3.
points that are on this line. Beautiful. That's the answer. The answer is always the points where they meet, right? Normally it's going to be 1 point. Sometimes it'll be no points. No solution here,
No
right?
solution.
This time you can't say infinite number. That's telling me how many. I want to know what they are. And you can't say all real numbers because the answer is supposed to be points. So what points? All the points on the line.
What points on the line?
On the line, yeah.
This is the answer?
That's the answer.
All points
Now
on the
think about it. Why does that make sense? The answer is always the points where they meet. If you draw one and the other one's right on top of that damn thing, how many points do they meet at? Infinite number. What are those points? Every point that's on the line. They don't meet at that point. They don't meet at that point. They meet at every point that's on this line.
Okay. The same meaning of the number of solutions.
Yeah, it's the same thing as all real numbers, just in 2 dimensions, right? All real numbers is when we had one letter in the equation. So if I start with x plus 1 equals x plus 1, I get 1 equals 1. The answer is all real numbers because there's just one letter in there.
Yeah.
Here I can't have all real numbers. It doesn't make any sense. The answer is supposed to be points, x and y. There's 2 letters in here, isn't there? I better have an x piece and a y piece. They must be points.
Yeah.
So they meet at all points on that line.
If I solve it as an elimination and I go to the answer, 0 is equal to 0.
That's the answer.
This is the answer.
That's what it's trying to tell you. Exactly. Cool.
Number 30.
4 1 has
Does everybody get that? Yeah.
At the end of the
Here?
no point.
No solution.
here, no solution. And this is one
If
solution.
they're parallel, there's no solution, right?
And if they
Parallel
intersect,
lines
it is
number
one
9.
solution.
Exactly. Cool.
Oh.
So tell me this real quick. What's the slopes of these 2 lines? What can you tell me?
Solving for x, I screwed that up.
The slopes of these 2 lines, how do they relate?
Yeah.
The same slope.
They must be the same, right?
What's
So,
the change?
in the slopes of these 2, they meet once. Don't the slopes have to be different? So if the slopes are different, there will be one answer.
If they're the same.
If they're the same, there could be no answers or
Infinite number.
infinite number of answers if they line up, right? So if the slopes are different, no freakiness.
So
If
if
the
the
slopes are the same, freakiness.
so if the lines
One
are,
of these 2 situations.
if the lines are parallel, it's either infinite or none.
If the lines are parallel, truly parallel, it's no solution because they don't meet anywhere. If they have the same slope and the same intercept, then they're the same line. And then where do they meet? Everywhere. All points on the line. Right? So again, if I told you that Farrah and I, if you add our age, let's say I'm twice as old as Farrah, right? And then I say Farrah is half as old as I am.
Same thing.
Could you solve that system? Could you solve it?
No.
Of course not, because it just told you the same thing twice. So here, what those dorks do? Yeah, here's some information. Here's some more information. No, they gave me the same piece of information, didn't they?
Because if you multiply the first
These
equation
are the same.
Because if you multiply the first equation by 2, you get the same
You get
numbers.
the second equation. These are the same, right?
Unless you multiply the first equation by a negative, then
They're
0
still the
equals 0.
same thing.
Yeah.
They are still the same. Yeah.
Be 0 equals 0 at that point.
Which shows you that they're the same. Yeah.
Could you do coordinates, please?
Oh, that's no answer.
I mean, I did it, but I'm trying to do the check and it's not matching, so it's probably wrong. Okay.
48?
Oh, okay.
Yeah,
Yeah, so 48.
that's what I had a problem with too.
Yeah, I don't blame you. 48 is probably one of the hardest problems in there. And it's just because the answer is ugly.
Yes, it is.
Freakiness, right?
Freaky.
I mean, I did the check, I checked one and I got it correct, but then the other one is not matching, so that means it's wrong, right?
Now your check could be where you made a mistake, right?
Oh, could it? Okay.
Oh, yeah.
No. But one
But
is matching,
let's see.
but not the other one.
What methods would you guys use? Would you use substitution here?
I wouldn't.
No.
I wouldn't either.
No, I used it.
Elimination.
Because what would you solve for? If you solve for x, you make fractions. If you solve for anything, you're gonna make fractions. And why do that to yourself when you don't have to? So obviously, I then want to use elimination, right? I don't want to graph these things. Oh my God. Why are something to be disgusting? Yeah, so here's the first one, here's the second one. So you could multiply to make the x's match up.
Yeah.
Notice one thing, that the y's already have opposite signs. You see that? So personally, I would, anything that's already opposite, I would use those.
Right.
Unless the other ones match up better. Like if that was a 2, I would use those.
First one by 8,
And the other one by
Yeah, so I can multiply the first one by 8.
and the second by 5.
So what do you get when you multiply this by 8?
You get 32 x, 24 y,
Minus
negative
8.
Alright, and then multiply this one by
15 x.
3.
15x.
Oops, we did. Times 3. 15x, yep.
Plus 24
Plus 24y.
equals 6.
See how the y's are going to go away now?
Uh-huh.
So you never add two equations unless something's actually going to go away. I always get people that add the way it's given and then they're like, what do I do now? Well, you go back in time. Erase that. You don't add them unless something's actually going to cancel. So here, if I add them, I get
47x equals -2.
47x, beautiful. And then these, of course, go away.
You always have to multiply in order to get something
You
to
end up
cancel.
with negative 2, and then negative 2 over 47.
Beautiful. I love it. So you're fine.
So you go
I
over.
did the first check. Like I said, I got it right, but the second one is not matching.
So how do you get the y?
You gotta substitute the x for the.
Then
You gotta substitute that into either one of these.
Yeah.
Right, I got.
Go down 2 and
13.
over 47 spaces.
Okay.
That's kind of hard to
Yeah,
grasp.
13 over 47 is what it should be.
Ain't that kind of hard to grasp?
That's what I have as my answer. But then I can't get
Wait,
my...
wait.
-47, that's before you plug in the x into.
Right here?
Yeah.
Well, so this, you're with me on this, right?
Oh, okay, never mind.
So now how do you get the y piece? Because on systems of equations, it's always a point.
Plug in the x. and
You can't stop when you get one letter, you gotta get the other one. So now if I plug it into 1, let's say, 4 times x, which is this, minus 3y equals -1. Cool? Just plugging in what I know x is. Now this is the place where a lot of you guys would just go, alright, I've done enough on that one. Or you'll go, oh shit, that's wrong. But when you get this far into the homework, you should expect it to get ugly, right? Earlier I'd expect whole numbers. Later in the homework, oh, this could happen. This could definitely happen.
I got that part
So you get, let's see, -8 over 47, right?
right. Right.
Alright, keep going. How do I solve for y?
And then 8 plus 47, you move it to the other
Plus
side.
8 over 47?
And then I end up with negative 3y.
Let me bring this up here. I mean, this is where I start to, I can almost feel some of you guys like turning off. Alright, I'll wait till he's done with this.
No,
Screw this.
You
Walk
still
up
do
the
that,
door.
Alright, I'll wait.
no, and then you add the
I mean,
whole
but this-
number.
I know it's ugly, but it's not impossible. You could do this. So what do I get now? I get -3y equals -1 plus 8 over 47, right?
Started by -1 over all over.
Careful. How do I put those together?
You gotta make the 47 a common.
Yeah,
right?
1 is the most awesome thing, because how do I make it over 47? 47 over 47, right? Because we got to multiply top and bottom by 47. -47 over 47 plus 8 over 47 is what? -47 of these plus 8 of these is
-39.
Divide that by 3.
yeah.
-3 to give it a problem.
Whenever I have fractions in a problem, isn't dividing by -3 the same thing as multiplying by -1/3? Oh shit. Let me see if you guys agree. Why am I going to do that? Because I have fractions in there. So I want to use a fractional next step, right? If I divide this by -3, look at that. Do you want to look at that?
No.
I don't want to look at that.
What if you just use a calculator and multiply by 47?
You got to know what to plug into the calculator, right? So if I do this to both sides, times -1/3, and am I not dividing that side by 3?
Yeah.
Dividing by -3 is the same as multiplying by the reciprocal.
Right.
3 goes into 39,
3.
13 times, and the negatives
Cancel.
cancel. So I get 13 over 47, so that's right, 13 over 47.
Yeah, I found that.
What's the answer? Oh, yeah, Manuel.
Could you just add
Yeah, I
47
have that,
to
but
get
I
each
can
side?
make one, I can
Say-
make
say
a
it.
check,
Could
maybe
you
my
just
check
multiply
is
47?
wrong.
Oh, yeah, you could, right here, you could multiply by
I mean,
47,
I
sure.
have it, I knew I had it right, but.
That's
then I
fine.
can-
That's your option, right? That's your option. So if you wanted to multiply by 47, feel free. The offset of that is you get these huge numbers, but at least you don't have any fractions. But that's totally always your option. Whenever you have an equation with a fraction in it, if you want to kill the fractions, you can multiply by the LCD. In this case, that would just be 47 because it's the only fraction, right? Nothing wrong with that. At the same time, I want you to realize this is not impossible. You could do this. It's not that difficult if you take it one step at a time.
So the order pairs is this one.
Negative 247, comma,
Yeah.
1347.
Do you think that this is an easier way done? But I'm thinking if you use to kill the x, then after you
Oh, sure. Another whole way to do this whole thing is once you get this, you could go back and multiply, like, I think,
-4.
yeah,
minus
multiply by
4,
-5, multiply by 4, and kill the x
and
directly.
you will get the same.
You could do that.
Yeah.
Okay.
In general, don't do that. In
Why?
general, that's more work than just plugging it back in. But since you got such an ugly answer, it might be a good idea to go back. Does everybody see what I'm saying? So we killed the y and got x. You can go back and kill the x and get y. Multiply this by -5, multiply that by 4, so those will cancel. That's beautiful, I love it.
But
Just in general, don't do that when you get a nice number here. It's
But this-
quicker just plug it back in.
it's
Yeah.
easier. For
Could be, yeah.
could be.
Sure. It's actually about the same number of steps, but just not fractions, yeah. Yeah.
So I got it correct, but I can't, it seems like I can't do the check. Could you do the check for the second one or no?
How do you mean? What do you mean?
Like, you know how we can verify to make sure that we have them correct? I did the first one with the first equation and I have it right. Could
Alright,
you
so
do
real
the
quick.
check on the
So
second one?
5 times x, negative 247s, plus 8 times y, 1347s, equals 2.
2.
Ah,
Yes.
did you say 6 or 2?
True.
Oh.
It's 2, isn't it?
No, it's 2. No,
Okay, okay,
no.
somebody said 6.
No, you know what? I have it as I have a negative 13. That's where I'm messing up.
Oh, there you go, okay.
There you go. Okay.
Alright.
Okay, thank
Alright, so enough of that problem, because that's the ugliest, absolute ugliest thing. On a test, I'm not going to necessarily do that to you, because I'd rather make sure you understand the idea of elimination, not let me throw fractions at you and mess you up.
Number 30.
You say necessarily.
Because at some point, I'm going to throw fractions at you to make sure you know how to deal with fractions, right?
Jeff, I'm going to throw fractions at you. Number 30.
30,
There, I threw one at you.
thank you. Oh, alright, 30 is not nearly as bad as it looks.
But it's freaky looking.
I know it's freaky.
Freaky.
Okay.
30 starts off ugly, but you can immediately make it better. What is it?
1/2 x plus 1/3 y equals 2/3. Then the second one is 2/3 x plus 2/5 y equals 14/15.
What is it?
14/15.
So again, what can you do whenever you have equations that have fractions in them? What's the first thing you can do?
Multiply by something?
Yeah, what should you multiply this by?
6.
Because that's the LCD, right?
Right.
Yeah.
Now, so right now, am I doing the step to make something eliminate? No. I am not even starting on this problem yet. I am just
Getting-
prettying up the equations they gave me.
Getting a common denominator.
So if I
right?
multiply this one by 6, what'll I get?
3.
Beautiful.
Plus 2y
3x plus 2y
equals 4.
equals 4. I love it.
Okay. The other one.
Multiply this one by
15.
15, and then I'll get
10x.
10x. Get in there.
Plus 6y.
Yeah, you see that? 15, 5 minus 15, 3 times, 6y. 15 cancels there, equals 14.
Right.
Now attack these two.
How does it cancel? Oh, wait, I forgot.
Because 15 to 50 cancels because he times.
Oh, wait, yeah, I forgot. Dumb.
So now that'll look a lot better.
Yes.
And to tell you honestly, do you see how a 2 will go in each of these?
Mm-hmm.
You could do that first. Or just multiply this by what to make the y's go away?
-3.
Minus 3, actually that would be quicker. Yeah. I'll let you guys finish that one out. Because that one step, it's a lot better to look at now.
13x
Believe it or not, you
plus-
get nice